Take the room temperature and the parametric pressure using the digital weather station available in the laboratory. Turning the apparatus on requires 3 main switches on the on switch cabinet. First, switch the whole system on by pulling the emergency button and turning the master switch on. Turn on the compressor by pressing button I on the compressor switch on. Allow the compressor to run for several minutes until the pressure in the pressure vessel of the second stage, P3, has reached a steady value. Using the throttle valve, regulate the pressure P3 to the desired value, between 6 and 12 bars. Please note that the system is set to run an emergency stop when the pressure reaches 12.6 bars in the pressure vessel of the second stage. Allow the compressor to run for 3 to 5 minutes so that the pressure P3 has reached a steady value before recording all the displayed data on the switchboard. Pressures and temperatures, along with the electric power supplied to the compressor, should be read from the display panel and recorded in a table. Repeat steps 3 and 4 for a total of 5 runs. Allow the compressor to run for 3 to 5 minutes so that the pressure P3 has reached a steady value before recording all the displayed data on the switchboard. Shutting the apparatus down. Using the throttle valve, reduce the pressure P3 to the minimum. Always press button 0 on the compressor switch first to activate the ventilating valve. The ventilation valve ventilates the line to the compressor, making it easier for the motor to start up. Turn the master switch off. Switch the whole system off by pushing the emergency button to the off position. Compressors, through the input of energy from prime movers, such as electric motors and combustion engines, pump compressible fluids from regions of lower pressure to regions of higher pressure. This compression not only raises the pressure, but also the temperature of the fluid. This heat of compression is partly dissipated by cooling ribs on the outside cylinder wall. The processes in the one-stage compressor can best be explained by examining the sequence of steps the piston goes through alongside the corresponding PV diagram. Compression. The piston starts from point 1, the bottom dead center, and moves up, reducing the volume and increasing the pressure and temperature of the air in the closed cylinder. Expulsion. Compression causes the pressure in the cylinder to increase until point 2, where the exhaust valve opens as the pressure equals or slightly exceeds the pressure set downstream of the compressor. The piston continues its motion, discharging air at constant pressure P2 and temperature T2 until it reaches top dead center at point 3. Return expansion. After point 3, the piston begins to expand the air remaining in the cylinder and the exhaust valve closes, causing the pressure to drop. Intake. Once the pressure decreases to equal the inlet pressure at point 4, the intake valve opens. Air is drawn in through the intake valve as the piston returns to bottom dead center at point 1, completing the cycle. Two-stage compression. As pressure ratios during compression increase, the maximum temperatures during compression increase as well, causing problems with maintaining lubrication and valve damage. To reach higher degrees of compression, multi-stage compression with intercooling is used. The intercooler rejects heat from the compressed air after the first stage compressor so that excessive temperatures are not generated in the second stage of compression. The cooler air also has greater density and occupies less specific volume, so the piston in the second stage does not need to perform as much work as if the gas were directly compressed from the initial to the final pressure. In this PV diagram, the gas is isentropically compressed from 1 to 2, allowed to cool between 2 to 1 double I, and is isentropically compressed from 1 double I to 2 double I. For single-stage compression, the gas would be isentropically compressed from 1 to 2 brine. The gray area between the two curves is the work saved by using a two-stage cycle.